Hello everyone, in this video we're going to be starting with the lesson Chemical Reactions and Equations. This is a very easy lesson. It does seem to be a little hard, but let's get started. Alright, so what does this say? Consider the following situations of daily life and think what happens when. So first, when the milk is left at room temperature during summers, it will get curdled. That is, it will get kind of spoiled, right? It's not gonna, it gets like paneer, like that. So an iron tawa or pan or nail is left exposed to humid atmosphere. So let's say an iron nail is left in an atmosphere for too long, it will get rusted. It's very simple. Okay. The next thing is grapes get fermented. Grapes get fermented means it will pretty much be like a grape wine, like alcohol. Because why? Because CO2, that is the carbon dioxide, when it's getting fermented, in the process of fermentation, carbon dioxide, ethanol, and it will release carbon dioxide and ethanol for the fermentation process, and this process again is known as fermentation. Okay. So the next thing is when food is cooked. What will happen when food is cooked? A new substance is formed. That's it. Okay, there is nothing much, and this is a chemical substance. What is a chemical reaction? It's a chemical change. It's not a chemical reaction, not a chemical substance. It's a chemical change. It's a chemical change. So when a chemical change occurs, we can say that a chemical reaction has taken place. So again, when food gets digested in our body, what will happen? Breakdown of complex substances. That is, some complex substances, we are intaking the complex substances, they will break down in and they will get digested. Okay, the food will get digested in our body. That's breakdown of complex substances. Cool. Next thing is when we respire. What do you mean by when we respire? Inhalation and exhalation. That's it. That is what will happen. So, in all the above situations, the nature and identity of the initial substance have somewhat changed. We have already learnt about the physical and chemical changes of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what actually is meant by a chemical reaction. So, we'll be learning about all of this in this particular chapter. So, first of all, I'm just going to mainly tell you, whenever a chemical change occurs, we can say that So again, I'm telling, whenever chemical changes occur, we can say that a chemical reaction has taken place. That is, a chemical reaction, first of all, a change is irreversible. In a chemical reaction or in a chemical change, the change is irreversible. You can't get the previous state back. Okay. So there is this very simple activity. So it is activity 1.1 in your textbook. So this activity needs a teacher's assistance. It would be better if students wear suitable eyeglasses. Clean magnesium ribbon about 3 to 4 cm long by rubbing it with a sandpaper. Why are you rubbing it with a sandpaper? See, because it has an oxide layer. It has a white layer on the edges. When we rub it with the oxide paper, with the sandpaper, it would promote the burning in a way faster mode. Okay. So the next thing is, if we hold it with a pair of tongs and burn it using a spirit lamp or a burner and collect the ash formed in a watch glass as shown in figure 1.1. So you can see that this is the magnesium ribbon. We are just scraping it with the sandpaper, and then we are holding it with a piece of tong, and you can see that here the sandpaper is there. So this is the burner. So this is the ash getting formed there. It burns with a dazzling light flame, and we'll even get like a tick 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 sound. You can see that later. So what do you observe? So first thing is that we can observe a dazzling light flame, and we can even observe that a chemical change we can't get it back. It's irreversible. So it can't get to its original form. So that is that this ashes is there, this magnesium oxide, this is reacting, this magnesium ribbon, this reacting with the oxygen, that is it's helping it to burn. So this will be formed to magnesium oxide. Okay, so this magnesium oxide is magnesium is reacting with oxygen, we will get magnesium oxide. So can this ash go to again magnesium? Can this ash be transferred to magnesium? No, because it's a chemical change. It is irreversible. Okay. Alright. You must have observed that magnesium ribbon burns with a dazzling white flame and changes into white powder. This white powder is a magnesium oxide. So this white powder is a magnesium oxide. So when this is burnt, it has a dazzling white flame and it will change into a white powder. This magnesium oxide is formed due to the reaction between magnesium and oxygen, which is present in the air. Okay. One main mistake that all the students do is that we don't read these. These are very, very important. Okay. So these are all the activities which we'll see, but wait for some time. Okay. Let me tell you. So take a few zinc granules in a conical flask. Wait, just give me a second. Yes, so first we have to take a zinc granules in a conical flask. There is a conical flask here, so we have taken some zinc granules. These are the zinc granules. So you can either add hydrochloric acid or sulfuric acid to this zinc granules which were already added. Okay, so you can see that there is zinc granule. This is the dilute sulfuric acid, and there are zinc granules. This is a conical flask where we are fastening it with a cork, and there is a little like straw which is it's just a straw. So what would pretty much happen is that this is the H2O, I mean hydrogen gas will be obtained. Okay, hydrogen gas will be obtained. So now we'll be learning about the chemical equations. So the first activity 1.1 is that is we saw that, right, the magnesium ribbon activity. In that we can see that when magnesium ribbon is burnt with oxygen, it gets converted into magnesium oxide. So it's pretty much when magnesium is there, oxygen is there. So when you're burning this magnesium, the burning of magnesium, what promotes burning of fire? Oxygen, right? So this magnesium, when it's burnt, and it just gets mingled, we can just say it gets mingled, or it gets added up, it collides with oxygen, and these would result in the formation of magnesium oxide. This gets converted into magnesium oxide. Okay, so if you noticed, you can see that magnesium plus oxygen, magnesium oxide, it's kind of a long sentence, right? It's quite long. This is pretty short, but it can be very hard, like FeSO4 and all that. So we can make them as symbols. We can even represent by them symbols. Word equation, this is word equation. We can even represent them by symbols and with the help of valency. Alright, so reactants and product. So what do you mean by that? So reactants means it's the magnesium and oxygen is, for example, a reactant. These both are reacting to form the product, which is magnesium oxide. You understand? So this is the reactant, this is the product. Or you can say that whichever is in the left side is a reactant, and whichever is in the right side, which is product. So the substance that undergoes chemical change in the reaction, magnesium and oxygen are the reactants. So in this particular thing, magnesium and oxygen are the reactants, and the new substance which is formed, which is magnesium oxide, which is the product. Okay, so this is not that important, but it's okay, you can learn it. A word equation shows the reactants of the products through an arrow placed between them. So you can see that there is an arrow placed between them, and the reactants are written on the left hand side, and that is the LHS, and the plus sign between these two reactants is between them. And similarly the products on the right hand side, that is the RHS, is the product, and with a plus sign between them. Where is the okay, I think there is some kind of mistake. And yeah, the arrow head points towards the products and shows the direction of the reaction. So the arrow, this is the direction of the reaction. Okay, this arrow just pretty much shows the direction of the reaction. That is it. This is pretty much very simple. It's just the structure of this particular reaction, how the reaction should be, like where is the reactants, where is the product, and all. So again, I'm telling you, reactants is something that is on the left hand side, which is pretty much whatever is combining together, and the combined product, that is the product that has formed from these two reactants, is going to be in the right hand side. And this whichever direction of the product will be this arrow mark, and this is the magnesium oxide. Magnesium plus oxygen will get magnesium oxide. Okay, so I'm ending this video here. There will be a part 2, part 3 and all. So the playlist will be in our playlist in our channel. So make sure you go and check that out. Thank you for watching this video. Bye.